In this video, we will look at the Arpeggiator project from Sound and Music Projects for Eurorack and Beyond. And this is a fun project to build on a breadboard. We have several momentary push buttons and a potentiometer and optionally an LED that can be used in the project. If we zoom in on the circuit, it looks complicated. It's actually rather simple. And if we just follow one of these cables, for example, we've got a push button. One side is going to one of the pins on the microcontroller, and the other side is going to ground. And you'll see the connection over here from the microcontroller for that ground rail. So all of these push buttons are handled in a similar way. We've got the wire going to a pin and then the other side coming to ground. And incidentally, the pins are configured for input using pull-up resistors, so internal pull-up resistors, and that simplifies the circuit somewhat. And of course, I talk about that in the book. If we take a look at the potentiometer, we're running 3.3 volts, and it's really important that you tie into the 3.3 volt and not the 5 volts that's coming in from the USB, because that will damage your microcontroller. So 3.3 volts going to one side of the potentiometer, the other side is connected to ground, and then the middle pin connects to one of the analog inputs. And we use that input to read a voltage, and then we can determine a tempo from that voltage when it's using its internal clock. Now if we take a look at the configuration on the computer, I'm using a DAW to test this, but I would really encourage readers to consider making this a project that would work, for example, with the Eurorack setup. If you to use the MIDI to control voltage chapter, this could be a great foundation for an Arpeggiator Eurorack project that would work well as a standalone device. But for testing today, I'm just using a DAW. So if we take a look at Ableton, which I happen to be using, we want to take a peek at the setup and make sure that under MIDI that you've got MIDI configured for the teensy for in and output. And especially down here, I'm using the Arturia as an input device to be able to play chords and such on the keyboard. And then we've got the teensy available here as well. And importantly, for output, we've got the track as well as sync. And so whatever DAW you are using, you'll want to make sure that you have it configured to send out MIDI clock, because the teensy will be responding to that clock in the arpeggiator. Let's also take a look at the configuration in the teensy project. This is in the Arduino IDE. And so you'll want to take a look under the Tools option and make sure you have the appropriate board selected. I happen to be using a Teensy LC, but any of the Teensy variants will work with little or no change to the code. Then we'd want to make sure you've got your port selected, and then importantly, under USB type, that you have the device set as a MIDI device. And this is, as I did talk about in the book, a really powerful feature of the Teensy controllers, is that they can emulate or function as standalone MIDI devices, and that's really powerful. You can plug in USB to your Teensy device and its functions and will be visible to the DAW as a MIDI device. And so that's how it's functioning today. To take a look at the function of the push buttons, we've got from left to right, we have pattern selection up and down. We have the rate, so that is the division of MIDI clock. And then we have the duration, so from legato to staccato essentially. And then the number of repetitions. And then finally, I use these taller push buttons for the active status. So if the sequencer is running or not. If it's in its hold mode, and in hold mode, you can play a chord release a chord and it will continue to arpeggiate, which is a feature I really like in an arpeggiator. And then the final two, we have a clock source. So selecting that option will toggle between the Teensy's internal clock or external MIDI clock from something like a DAW or another source. And then finally, there's an option to restart the sequence, which is that last push button here. So if I were to, for example, toggle on the active mode, I have this set to internal, and you'll see that we have LEDs lighting, and as I adjust the potentiometer, you can see that the tempo increases. Okay. And one of the things in code, if we just take a quick look, that magic, if you will, is handled first through a callback function, a MIDI callback function, and this is these functions in here for handling real-time events, a system, a clock. And then notice in the main loop, there's just a single if statement. There's a global Boolean that tracks whether we're in the internal or external mode. And there's just a single line that will either track the tempo pot or enable it to function from the external clock. And that magic all happens in this simple function here. If the internal clock is active, and then it calls the do clock function from the timer. And that same function can be called from a callback function as well, which is this handle real-time system function here. And so the do clock function works the same for internal and external. It just makes it a really convenient way to configure the code for this project. Let's take a listen to the arpeggiator. And let's adjust tempo. And so on. And of course, I just have that running through a virtual synthesizer in the DAW. But again, you could use concepts from the book to output UART MIDI, output to a MIDI to control voltage device, or directly convert the MIDI to control voltage through circuitry. So in any case, I'm going to turn off the active status. Let's switch over to the external clock. And so now we'll have the DAW controlling it. And so here we go. And if I press play on the DAW, I've got a little drum loop going. When I press active, you can see that's synchronizing. And so on. So let's try the hold function. I'll press this to toggle hold. I'll play another chord. And as I play it again, it turns it off. Okay. And let's experiment with the rate. And slower. Let's try duration. Turn that up a little bit. And let's try repetitions. And the rate. toggle to the internal clock. Back to external. And so on. So that's a lot of fun, and really a fun and fairly simple project to build on the breadboard. And to me, the beauty of programming your own algorithms is that this is one of the few times, and I talk about this in the book, it's one of the few times you actually hear your algorithms at work. And while programs like Ableton and Logic and many other programs have some wonderful arpeggiation effects, there's something cool about being able to design your own. And for example, using things like genetic algorithms that we'll talk about in the next video. So I hope you enjoyed the video.